Welcome to a new test and teardown video. This time it's a German Siemens Magnetfeld Messgerät. So this one measures magnetic fields. There's a Betriebsanleitung, so that is a user guide. I'm sorry, but it's written in German. This says exactly what you need to do. Ooh, you need to turn the messen. Okay. And there's actually a battery inside, so that is something I am a little bit scared about. Remember, every time I find old batteries forgotten for 30 years inside old electronics. So there is this switch, and this is also a little bit weird. Look at that. It says turn off, aus, after use. So this is of course aus, and messen is to measure, and laden is to charge. So there's a mains power connector down here. I will show you in a second. But there's no response, of course, on this meter in any way. There's a switch here. And then we got the different ranges. And then there is a times 50 amplifier or normal ranges. I don't know what that is. Maybe that is 0. Or somehow there's also a 0 here. Well, why do we have this? And here is the probe. Yes, there's a little bit of text here about blah 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 blah. You should hold this in your hand. Okay, cool. So this probe has been modified a little bit with this plastic. I think this is to stick it in to something, right? And this piece of plastic here is super flexible, by the way, almost like rubber. And here's of course the whole sensor. It's really dirty out here, and it looks like it's been. You stick this into something and to measure the magnetic fields. So yes, this one measures in Gauss, and as you know, we got 10,000 Gauss to 1 Tesla. So this is a very sensitive instrument, super fine magnetics. So I can't wait to see if I can get this up and running. Should try with the highest range first, I guess. And then find a tiny little magnet, and then get it closer and closer to the probe. Very careful. And let's look at the side of the instruments. Oh, there's a nice Siemens logo here, and here is this power supply. There's no. Oh yeah, there's actually a little logo here at the end. Let me show you. Here it says, so the type number of this one is Z264-001, and then there's also a Siemens manufacturer number, or whatever that number is, Y12-018. And if you Google this, you're not going to find anything at all, but you're going to find one that looks a lot like this, and it's called a 234. So that is the type you can find online. I guess this is how we open it. So there's probably a totally leaked battery inside. So probably I should go and open it first. We are inside. And my assumptions they were right. I am sad to say there is a leaked battery in here, and I need to take this away. But look at that. Positive is connected to a black wire. That is definitely a stupid thing waiting to happen. So somebody replaced this battery, and the guy who replaced it didn't mark the wires or write something here, and we got some other wires here. Okay, I need to look a little bit deeper into this. We've got all sorts of inductors here, but I think that's actually resistors, because I think this is a pure DC product, but let's wait and see exactly what is going on here. Then we got an op amp. That is a new modification, and here is a little switch mode converter. Look at that. And that will be the 0-pot meter. Got the trimmers here. We got some different things right there, right? So, and here, let me show you guys. Careful. Mains transformer is down there, right? So this is our mains entry, and this is our measure charge switch. And there is definitely something wrong with that switch and the stops. There were supposed to be 3 positions and then some stops. But if you break this real hard, or try to turn this real hard, you're actually bending the stops, and this is what you see here. So I'm a little bit sad about the color codes for the for the wires here. We got 3 of them. One is earth. That is also gray. That is a little bit stupid. It should have been the other way, at least, if you only got 2 different colors, right? And that is the mains entry connector, right? And there's a schematic here. Let's have a look at that. So here is the schematic inside the case. That's actually a nice service. And here is the battery. It says 1.3 volt. So it's probably one of those nickel cadmium cells. So there's of course a charger you can connect to this, and then there is an on-off switch or some stuff here, right? And then there is a 2 megahertz DC-DC converter that is generating plus and minus 3 volt. This is probably regulated, right? So that will go to a Hall probe, and the 2 outputs of the Hall probe will go through this switch. This is the normal mode or the gain mode. So in normal mode, it goes directly to the meter, and then it's disconnected here, right? But in gain mode, see, the inputs go to this op amp, and that op amp is also running on the plus minus 3, and then that output drives now the meter. See? So that is actually quite smart, the way that they made this. They say that those resistors here, they are accurately measured 50 times current amplifier. Alright. Could have been cool to add your name and a date. So please always do this when you distribute drawings like that. It's so much fun to see a name and a date. Well, let's get back to restoring this nice unit. I kind of really like this meter. I think that most of all the cool and intelligent stuff is actually done inside the meter, because we see voltage is applied to the meter, and we got some measurement stuff here. We got some, what is that, milliamps and ohms and whatnot. It's actually a very, very complicated instrument, this one. And we actually also got 2 different instruments in one, as far as I can see here. You see, we got the main instrument, but there's also another instrument down there, right? I don't know if this will move, but there's definitely another instrument in here, right? That looks really, really nice. Let me try and fix that battery here. The selenium rectifier here tells me a lot about this unit's age. So that is 1960, 1970, in that range. Nice selenium. That's of course also Siemens. But I mean, if it works, I'm not gonna poke around with that. So this is our mains input. And yeah, I was right about this switch being a little bit destroyed. Can you see it's bent here? This one is not supposed to look like that, right? And it's definitely not going to It's not supposed to be able to move that much. So that is difficult to fix because we have those two screws down here, and this is the end stop. That one is supposed to touch that little thingy. I don't know. I'm not going to fix that, but I'm going to look at the battery and see if we can get this thing to measure something. Yeah, I was right. NECD. Nickel cadmium. Look at the corrosion here. It's all the way through the casing. So all we have to do is remember the two black thicker wires. They are ground. And then there's a thin black wire that is positive. I think I will replace this wire because that is an accident waiting to happen unless you add some text or something in here, right? But first we need to get rid of this stinky old cell here. Oh, well, that is bad. Oi, oi, oi. Okay, that was real easy. So this black wire, the positive battery wire, goes here and it goes to that point here on the switch. So that will be super easy for me to desolder that wire and put in a red wire. Haha, then it should work. Because that, we don't want any accidents waiting to happen, right? Also got a little bit of corrosion here. So it reels a little bit like this was not the first time. Or we also got a little bit of corrosion here. So probably all this area was full of a little bit of acid dust or some, I don't know, chemicals. As you can see, parts close to the battery was actually affected a little bit. But I'll try and clean it a little bit and see if I can get this up and running real fast. So here's what I've done. Now with the nice red wire, I connected the battery to my power supply. And I also figured out what that meter here in the middle is. I don't know if it says that anywhere. Of course it says in the user guide inside the lid. But here they could have written battery OK in the middle here, right? See, if I go measure, that here is the battery voltage. Let me hold this and change the battery voltage. This is 1.3, 1.2, 1.1. So that is quite alright for a nickel cadmium cell. Now it's 1.3 for fully super duper charged. And look what happens now. I am in measure. And I just put it to that range. I put it in normal mode. And now I take a tiny little magnet like this and hold it to the sensor. And then it goes up. What do you know? And the fun thing is, if I rotate the magnet, so it's the other side of the magnet. Oh, look at that. It goes negative. So all that works perfectly fine. I mean, this is really nice. It really, really works. And let's try this amplifier. See, it just goes up here and goes in oscillations. And if I come with my magnet, see, then there's gravity crap. So the problem here is, this is the switch. It's that simple. Look at that. Let me, yeah, it is that simple. How typical is that? So now I've been poking around with the different ranges here. I do get some, see? It's actually getting a lot better now. And then I take my magnet. Ooh, now it's super sensitive. Yeah, let me see if I can rotate the magnet right. Yeah. And then see? It goes stuck in the middle and then... So that is the thing. You need to discharge the circuit with this one. And then it works again. But it's funny, it stops at the middle like that. See? And then it kind of stays. Funny. Maybe there's a mechanical problem here as well. Because that can't be right. I'll play a little bit more. Boing or something, and then doing like that, right? Yeah, that looks like a mechanical problem. Well. Let me try and measure the voltages in here. Yeah, by the way, here's this homemade 3 megahertz switch mode converter, and it actually works. We got plus minus 3 volt on that op amp, so all that here is actually working quite alright. By the way, this pot meter here is 6 ohm, right? Look at that. This is really a nice pot meter. So this is the way that it is connected to the sensor pin via this kind of spring. Isn't that nice? So this is not changing its resistance. It's just a good way to do that. How cool is that? But anyway, I don't want to play any more with this right now, because I think it's going to take 2 years to figure out how to get into that meter and that mechanical problem. But anyway, that was a super fast video about this magnetic measurement unit from Siemens with a little single cell and a charger, selenium rectifier and stuff. But where is the series resistor for the charger? And why are we having this big thingy here? I don't know. So many questions and so little answers. Oy. That'll be all the bridges for the whole element. It looks a lot like copper, but I think that is just a coincidence about this varnish they put. So those are of course resistors, and you can also see the values written on the different resistors. Super accuracy, hand wound resistors and measured to the last little detail. So that is really cute. It's quite old, definitely. And super high quality, those switches. Look at the size of the contact. And they're actually quite tough to turn here. Alright, that gotta be it. See ya. Thank you. Bye.